Carbohydrate absorption. So we know that carbohydrates start chemical digestion in the mouth with salivary amylase. Doesn't do much once it gets to the stomach, and then once it gets into the lumen of the small intestine, that's when the rest of digestion occurs and then absorption. So I'm going to draw a small intestine cell, or a couple of small intestine cells. So this border down here is the basolateral surface. Okay, and then up here is the plasma membrane that's facing the lumen of the small intestine. So the lumen is up here. All right, and I'm going to erase this carbohydrate absorption right here so it doesn't get in my way. But that's what we're doing. Okay, so here's my cells. And this right here, this stuff right here, is microvilli. And once the carbohydrate gets into the small intestine, we're going to have, of course, pancreatic juice that's in there, and in that are pancreatic amylases. And those start to continue to break down the carbohydrates into their smaller and smaller forms. So once they get down to disaccharides, that's when they will get near the plasma membrane here, the microvilli, and this microvilli has a name, and it's called the brush border. And the monosaccharides, so meaning sucrose, lactose, and maltose, these are the disaccharides, and they come near the brush border, and at the brush border there are enzymes, and those enzymes would be, I'm going to put that in a different color here. So the enzymes would be sucrase, lactase, and maltase. And those enzymes break these disaccharides down into their monosaccharides. So we're going to have glucose and galactose and fructose. So I'm doing this separately. I'm doing glucose and galactose together because they come into the cell the same way. Fructose is a little bit different. So we'll look at glucose and galactose first. So glucose and galactose enter the small intestine cell through secondary active transport. So along the cell membrane here, there's a special transporter, and it's called SGLT, S-G-L-T. So sodium glucose transporter. Okay, and this transporter is a symporter, and what it does is it brings in glucose and galactose using sodium. So we know we have sodium out here, and there's sodium outside of the cell. And as it moves into the cell through the symporter, it brings in glucose and galactose. Okay, and again, that's just secondary active transport. Now, the glucose and galactose, as they come into the cell, are going to start to fill up the cell, and the gradient for the movement of that is going to go down. So we want the glucose to go into the blood. So if we're down here, we have our capillary beds, or capillaries here. We want to be able to bring glucose into the blood, and we also need to maintain the gradient for sodium to keep on bringing in that glucose. So along the basolateral edge over here, we have a special thing called the sodium-potassium pump. Okay, and the sodium-potassium pump is going to pump out sodium into the blood, and of course it's going to bring back in potassium. Okay, so that will get the sodium out of the cell and keep the gradient of sodium coming into the cell from the lumen so that it can bring in that glucose and galactose. All right, fructose, and we'll come back to glucose and galactose in just a second, but let's get fructose into the cell. So fructose is a little different. It moves into the cell basically by diffusion. So there are other, this isn't really a transporter, this is more of just a channel, okay? And it's called Glut 5, I think it is. And fructose will come into the cell just by diffusion, coming in, because there's more fructose on the outside where you've eaten than there is on the inside here. So fructose comes right in. Glucose and galactose need a little help. All right, so fructose, glucose, and galactose then can enter the bloodstream. So there is also another, get purple here. There's another transporter on the basolateral side, and this is a Glut 2 transporter. And this will allow the glucose, galactose, and fructose to go into the bloodstream. So we have glucose and galactose, and we have fructose that will come in. And once in the bloodstream, then they go towards or go over to the liver to be processed. Okay. So potassium is over here, and we've got the sodium potassium pump going on here. But remember, this is potassium, and all potassiums have leaky channels for potassium, so it just goes right back out once it's in. So that is basically how, or that is how, carbohydrates are absorbed into the blood. Okay, and again, everything that we eat, everything that we consume goes into the blood and heads over to the liver to be processed, cleaned, and all that stuff. So in the next video, I'm going to talk about the absorption of proteins.